In section 1.2, we're going to learn about mathematical patterns. Or actually, we're going to review mathematical patterns. We're going to define key terms such as sequence, sequence notation, recursive functions. We're going to learn to create graphs of a sequence using our calculator mainly. And we're going to apply sequences to real-world situations. Okay, so first of all, let's start with the definition of a sequence. It's going to be an ordered list of numbers, and each number in the list is called a term. An infinite sequence is going to have an infinite number of terms. For example, here you notice the 2, 4, 6, 8, 10, the dots here mean that this is going to be an infinite sequence. And again here with the 1, -3, 5, -7, it's going to be an infinite sequence of terms. So it's a pattern that you could figure out, which we'll talk about here in a few minutes. Sequence notation. The first term of sequence is going to be our use of 1. So that's our first term. Second term, we're just going to use a 2 in the place of that 1. After that, we're going to look for the nth position. So that might be the third, the fourth, the fifth. And that's going to be the nth term there, the use of n. And then the term before use of n is going to be use of n minus 1. So we could say use of 1 to use of 2, 3, okay, and that's the order that they would come in. Okay, here's an example. What we're going to do is look to continue this pattern. We're going to draw the next 2 diagrams, and then we're going to write a sequence that represents the number of circles in each diagram. Okay, so let's give ourselves a little more room. Okay, and so we're looking to continue this pattern here. And you notice you start out with 2, and then from that you're going to add this, and this. And then the next time, then we're going to add a few more. So what you could do is actually you could start from one of the ones we have, and then, so let's say I want to start from this one here. Select this, and let's clone that. So I'm definitely going to have this one. And to that, what I'm going to add is 1 at the bottom. So let's do that. And then I also add 2 more at the top, because each time I'm adding 1 at the bottom and then 2 at the top. And so eventually you could figure out what that's going to do for you is adding 3 each time. Okay, so looking at the pattern here, so we start out with 2, and then we move and we have 5, and in the next pattern we have 8, and then in this one we have 2, 4, 6, 8, 10, 11. So we're actually going from even to odd, and so then you can go and figure out, well, in the next pattern I'm going to add 2 up top and 1 at the bottom, so I add 3 to that one, 3 to the previous, and then that's going to give me 14. So there I've continued the pattern. Okay, so we would get 14, and let's erase this one. Something like this. Okay, so from here what we're going to do is just go ahead and find the sequence that's going to represent the number of circles here. So in step 1 we have 2, step 2 we have 5, 3 we have 8, 4 we have 11, and then in 5 we're going to have 14, and then this would continue. So as a set, the set of numbers that we have there is 2 and 5, and I'm just looking at the number of circles that's going to occur here. 8, 11, 14, and then of course that's going to continue. It's infinite. So in sequence notation, then what we would do is say, instead of step 1, 2, 3, we would say the third term is 8, and the fourth term is 11, fifth term is 14. And then we have our sequence. Okay, so let's go ahead and look at the next example. Here we're going to graph the first 5 terms of a sequence, 2, 5, 8, 11, and 14. So just to graph, this is just going to be a quick review of graphing using your calculator. So first of all, right now I'm going to change this over so that I'm in function mode, which most of your calculators are probably there in function mode already. I'm going to go to Stat, Edit, and if I have any numbers in here, I'm going to clear those out. You can just go up here and press Clear, Enter. And to L2 now, Clear, Enter. All right, so if I want to enter that sequence of numbers that I was talking about, let's go. That way I can see them. So we have 1, 2, 3, 4, 5 terms that we're going to enter. So I'm just going to go through here and say 1, 2, 3, 4, 5. 5 terms. And now I'm going to enter the terms. So I start with a 2, and then I have a 5, an 8, 11, and 14. And you notice these are the terms from the previous example. Okay, so I have all of those, and now I'm just going to do zoom stat, which is zoom 9. And nothing shows up, so that tells me my plot's probably not on, so I'm going to y equals, go up, turn on my stat plot, and now let's try zoom 9 again. And there I have a graph of those, just using my calculator. Okay. So there's that example, which will come in handy using the calculator to put those in and the next couple of examples. Actually, we're going to look at a different mode too. Okay, so now we're going to talk about a recursively defined sequence, and this is going to be when you're given the first term, and there's a method of determining the nth term by using the terms that precede it, then you can come up with a recursive formula for. So in doing that, we're going to use this notation. This is going to this is going to be the nth term of the sequence. Okay. The first term of the sequence, we're going to use of 1. And we do need to have a first term of the sequence if we're going to come up with a recursive formula. And then this is going to be the previous term of the sequence. So meaning previous to this. So like 5 and 6. So this here would be 5 and this would be 6. So here we're going to look at the sequence. We've got 1/4, 1/2, 1, 2, and 4. And we're going to find it recursively, find a recursive formula, and then we're going to graph it. So first of all, I notice that the first term in my sequence is 1/4. And you can start looking at a pattern to see what happens. Probably pretty quickly you notice that if we take a 1/4 and multiply by 2, we get a 1/2. So for the second term, I know that I can say 2 times the first term, which is 2 times the 1/4, and that's going to give me the 1/2. And for the third term, I can say 2 times the second term, which is 2 times 1/2, which is going to give me 1. And for the fourth term, I use 2 times the third term, which is 2 times 1, which is going to give me 2. And then for the last one, the fifth term, it's 2 times the fourth term, which is 2 times 2, which is equal to 4. And there we have the 5 terms in that sequence. What you notice that we use as a constant every time is this 2 here. So that means that's going to be in our recursive formula. We were given an initial term, which is 1/4, and we can use the previous term to find the nth term. So that means that we can come up with a recursive formula. We know we're going to use 2 times the previous term. So that's our n minus 1. And then we have to say 4. Okay, so we start with a first term here. So when we use our n minus 1, we want this piece here, we want this to return a 1 for that first term we have. So this is going to be 4n greater than or equal to 2, so that when we plug in 2, the very first term we use would correspond to this. Okay, so there's our recursive formula. Now we're going to look at this. We're going to look at a graph for this one. And let's just do this one like we did the last problem. I'm going to stat. I'll edit my list. Actually, we did. No, we have not. Okay, so we start out with 1/4. So the first term is going to be 1/4. The second term is going to be 1/2, and you can also put decimals in. The next term is 1, then we have 2, and then we have 4. And let's look at a graph for that. And here we have our graph. Okay, so let's move on to the next example. This time we're going to try an application, and we start out with a basketball that's dropped from a height of 8 feet. It's going to hit the floor and bounce to a height of 6 feet. It's going to continue to bounce, and on each rebound it's going to rise only 3/4 of the height of the previous bounce. So we're going to do several things here. We're going to write a recursive formula. We're going to create a table and a graph showing each bounce, and then we're going to find the height of the ball on the 5th bounce. So I think, again, let's go ahead and use our calculator, but this time we're going to try something different and change the mode of our calculator. So let's do a couple of things here. This up. So on your calculators, or actually first, let's go back here and go ahead and come up with a formula, a recursive formula for this. So when we're talking about part A, it pretty much tells us it's going to rise only 3/4 of the height of the previous bounce. So that means that when we're coming up with our recursive formula, we're going to start with a, instead of starting, it's at 0, it's at 8 feet. After no bounces, it's at 8 feet. So we're going to start out with 0 this time instead of on 1. So that's one thing you need to remember. So when we're coming up with our nth bounce, then it's going to be 3/4 of the previous bounce. And this time it's going to be 4. N is greater than or equal to 1. And the reason that's greater than or equal to 1 now instead of 2 is because when we plug into n minus 1, we want to get this 0 here. Okay, so we've got part A taken care of. Now part B is where we are looking for a graph and a table. So we're going over to our calculator. I want you in your calculator to go to the mode, and you're going to go down, and where it's on function now, you're going to change that over to sequence. Press enter. Okay, and then go to your y equals, and it should look something like this. And I already have the information plugged into my calculator here. So the minimum, the n minimum is going to correspond to this. Okay. So it starts out with no bounces. So that's that n min is 0. U of n is going to be just our recursive formula. So we've got 0.75, and then you're going to use your second 7 key to pull up that u, and then your n minus 1. And then for the n, you notice that is our variable this time. So you're just going to use your the key that you usually use for x on your calculator. And then your u and u of n minimum is going to be, what does it start at? So that 8 is going to be the starting value. And you use the brackets that are above the parentheses. So you're going to have to use your second key for those. So let's look at this. Okay, so let's make sure we get this right. This right here is going to be, this is going to correspond to the step, the first step, which we started at 0. This is going to be our formula. And this here is going to be our starting value or starting height, which it started at 8 feet above the ground. Everything else we're going to leave alone for now. All right, let's go back over to our calculator, and we're going to look at our window really quick. So I want you to start with a minimum at 0. Your end minimum is 0. The max, let's go up to 10. Let's say after 10 bounces, because it's asked us to find the 5th bounce. So if we go to 10, then that's plenty. We're going to start the plot at 1. We're going to leave those two plots at 1, start and step at 1. The x minimum, right now it's at 0.6. Let's just change this to 0. And let's change our x max. We're going to go, how many, if we think how many times we're going to plug this in, so we can go up to 10, should be fine. Scale, we're going to leave that at 1. And we talk about the height of this. So our y minimum, let's let this y minimum be 0. And our height is not going to go above the 8 that it starts at. And so let's look at a graph here. And I still have some information from a previous graph, so I'm going to my y equals, and I'm going to cut that off. Go up to plot, enter. That's off now. And let's go and look at the graph here. So here we have it. So let's, what we have here. Okay, now we have all the information I think we need for this. So for this problem now, you can see each of the bounces. So it started at here at a height of 8, and you notice going down 3/4 each time. Okay, so there we have our graph, and that shows us 10 bounces. Now if we go back to our calculator, then all we have to do is trace, and once we trace, we can see here's the second, after the first bounce, it's at 6, and then the second bounce, 4.5, third, fourth, and the 5th is what we wanted to know. Okay, so at the 5th bounce, we're approximately 1.9 feet off the ground. We can also look at the table on this. Second graph should show us a table. Okay, here it comes now. So instead of pressing trace, you could also go and look at the table here to find that after the 5th bounce, we're at 1.9, approximately 1.9. Okay, so let's move on to the next example. Okay, we have another application, and Rick owns an automobile dealership. Last year he spent $1,600 on advertising, $16,000 on advertising. He plans to increase his advertising expenditures by $1,200 this year and each subsequent year. What will the amount he spends on advertising in the 6th year be? And we're going to find a recursive function to represent this problem, as well as a table and a graph. And so we do that very much like we did the last problem. So let's start out. We know that year 0, which would be this year, he's spending $16,000. Year 1, he's going to move that up because he's going to spend an additional $1,200. And this is going to continue for the next several years. So recursive formula, we can do that pretty quickly, is going to be our previous value plus $1,200. And this is going to be 4n greater than or equal to 1, because we're starting out at year 0. So there we have our recursive formula. We can go and look at a graph for this. You could, I mean, since we're just looking for the sixth step, you could pretty easily plug that in and find out what would happen on the sixth year. If we want to use a calculator for this, let's do one more example here with a calculator. You notice our numbers are a lot larger this time. So that makes things, that makes when we set our window, that makes it a little more difficult to set our window. Again, we're going to start with the minimum at 0. We're going to change our recursive formula to, let's delete this. And we're still going to use our previous term, but this time we're going to add to it $1,200. Okay? And so our first term this time is not 8, but our first term we're starting out with $16,000. So, okay, there's our $16,000, and let's close those brackets. Okay. So let's leave that alone. Okay, so let's think about our graph for a minute. We want to go at least up to the 6th term. So let's maybe go to the 10th term, but this is increasing at $1,200 and it's starting at $16,000. So maybe if we went up to, like, we could say maybe $30,000. So we're going to leave the x min at 0, or our n min at 0. Our go to 10. We'll leave those two at 1. We'll go 10 steps just like we did, and leave a scale of 1. Now our y is where we're going to want to change things. We can start at 0, but we want our max to go way above 8. We want it to go to like 32,000 maybe. And that's just sort of a guess because we're starting at 16,000. And we don't want to count by ones. Maybe we should count by something like 5,000. And then we can always adjust this if it doesn't look so good. And let's look at the graph now. And this is what we see. So let's just make sure, let's trace and make sure we're getting the right information here. So at 0, we're at 16,000. After the next year, we're up to 17,200. And then you see after 3 years, 4 years, and 5 years. So 5 years in, we're at $22,000, and it asks us for the 6th year. So at the 6th year, we're at $23,200. Okay, so at 6 years, it's going to be cost of $23,200. Okay. All right, and let's look at one more example. And this one, I'm actually going to get you to do this example. So here we have triangular numbers, and they're represented geometrically here. And what I would like you to do is to find the recursive function for this. Okay, so you're going to find the recursive formula for this. And then after you find the recursive formula, you're going to find the 20th triangular number. And you can bring those into class tomorrow. So this is a formula. So bring those into class tomorrow and we'll review it. And that concludes section 1.2.